To understand Kafka, let's take this very simple example. Let's say that the user buys something, and after the order is completed, we need to, from order service, we need to send a notification to payment service, to inventory service, and to shipment service in order to deliver the order. So one way to do that is that from the order server, from the order service, we are calling the payment, inventory, and the shipment service separately. But this approach introduces a lot of problems. One of them is that we need to call all of these services separately, and we need to, in case of the exceptions, we need to handle those exceptions and so on. To solve these problems and many others, so what we do is we introduce a central hub, central messaging system, central real-time messaging system, such as Kafka, in order to handle these problems. So in our case, right, what we do here, so instead of calling all these services separately, we are publishing messages to the Kafka, and from the Kafka, all other services that needs to process those messages, they are consume those messages, and they process those messages. So in Kafka, we can produce not just from one service, so it's a many-to-many, which means that the many services can produce messages to Kafka, and the many services can consume messages from Kafka. In Kafka, the messages that are published to Kafka, we are calling them producers. So for example, in this case, let's say that we have 3 instances of order service. It's microservices, and also it's replicated. So we are so for each instance of the microservice, we are publishing to Kafka. So we have many producers. And for the consumers, when we are consume those messages and we are processing those messages, we are calling them consumers in Kafka, the term that we are using. So we have many-to-many relationship. Many producers can produce to Kafka, and many consumers can consume from the Kafka and process those messages. But where exactly we are sending those messages, right, when we send to Kafka? So for example, in this case, we have orders, but also we may have a payments, and we may want to send another message, payments message, and we also want them to be consumed by another service and produced. So in Kafka, we are using a term called topic. So in this case, we are creating an orders topic, and we are sending messages to the orders topic, and the same payment, inventory, and the shipment services, they are consuming and the processing messages from the order service. But how we are scaling in Kafka? The way we do that is we are dividing topic into partitions. So for example, we know that let's say that we know that the orders topic, the number of the messages will increase. From today we are receiving 100, tomorrow we will receive 1000, and later we will receive 10,000, millions, and so on. So the way we scale that, we are dividing that topic into partitions. In our case, we divided that into 3 partitions, and also when we're creating a topic, we are mentioning what's the replication factor. So what's that mean is, for example, in this case, partition topic 1, we want that we want that also replicated in the other instances. So we have here 3 machines for the Kafka, and we have one main machine, and we have our leader machine, and we have 2 follower machine. We want the partition 1 also replicated to other instances. We call them in Kafka brokers. So in this case, we have 3 brokers. One is the main, and the 2 other one is the follower. So when, let's say that we have replicated the message for the partition 1, 2, and 3, we have replicated into other instances also, and let's say that our main instance is crashed, then in that case, Zookeeper, that is used with the Kafka, Zookeeper will promote one of the follower instances to the as a leader instance in Kafka. So to sum up what we have for Kafka, right? Why it's one of the widely used technologies nowadays. The first one, it's a scalability. It can handle millions of messages per second, and we can handle easily. The only thing that we need to do, we need to add more partitions. Let's say we have a topic that today consumes 100 messages, tomorrow maybe 1000, then it can increase to millions. And then in that case, we just need to we need to increase the number of the partitions and the number of the brokers and the Kafka will handle it. The second one is durability. Data is written to disk and replicated. So as we have seen earlier, we have let's say 3 brokers, right? And the message, when the message is received, message is also replicated to other instances. And if the main instance is crashed, then the Kafka, in Kafka we are using Kafka with the zookeeper. Zookeeper will promote one of the followers. It will promote one of the followers to the as a main broker. The next one is the performance. It's super low latency. It's near real time. So the messages that we are processing, they are, if we take the what is the in milliseconds, how long it took for us to consume the message from Kafka and to process it, so the latency is low. So the fourth is decoupling. Decoupling means that producing and consuming, so we are decoupling these two processes. Producer can produce messages to Kafka independently from the consumer. So we don't wait for the consumers to consume the messages and then produce. The consumer and the producer work independently. And the last one probably is the replay. Replay means that, for example, let's say you are consuming the messages and at some point you haven't processed the messages correctly, or let's say that there was some bug or similar kind of an issue, then we can, from that topic, let's say orders topic, we can start to consume the messages for the last 24 hours. We can start to consume those messages again.